This video is on balancing reactions. Before we can balance reactions, we need to know the parts of a chemical reaction. On the left, we have reactants. And on the right, we have the products. Now, reactants react together. There's an arrow, which means yields or produce. And then they produce products. Inside of our chemical formulas, we have subscripts. And they tell us how many of each atom we have. Remember that ones are not written. We can add to our chemical equation coefficients. And that's just like in math, a coefficient can get distributed throughout my formula. So to balance this, I would need the following coefficients added on to the front of my formulas. Now my coefficient here of 2 distributes to the C and the B. So I have 2 C's. Initially I had 3 B's, but now I have a 2 in front, so 2 times 3 would give me 6. When we are balancing chemical reactions, we need to keep into account the law of conservation of mass, which states that mass or matter cannot be created or destroyed. This also applies to atoms. Atoms cannot be created or destroyed. We can't just make them disappear. They have to go somewhere, and we have to keep them accountable. A couple tips to balance a chemical reaction is start at the left and work your way all the way to the right. You must go all the way through before you and check your amounts. If you don't go all the way through, you'll start to get here, go back, go back, go back, and never have done anything with your second one. And you kind of go in this downward spiral. It's much easier if you go all the way through first, then go back and check. If you've gone through twice and things haven't worked out, erase your coefficients and start over. It's the easiest way to catch a mistake. Another thing that can help is to draw dots or lines so you count the atoms inside of your formula. Be aware of your diatomics. Remember, that means 2 atoms. And those are special nonmetals that don't like to be by themselves, but are rather bound to another one of their atoms. So that's why there's a 2 after it. Everything else, every other element, is as seen on the periodic table. So for example, aluminum would just be Al. Whereas if we see the word oxygen, it means that we have to write O2. So let's do some examples. I have sodium reacts with oxygen to produce, there's my arrow, sodium oxide. So that means sodium is a reactant because it reacts with oxygen, a second reactant, to produce sodium oxide, a product. Sodium, found in the periodic table, is just Na, an element, with oxygen. Oxygen's a diatomic, so it's O2, to produce, there's my arrow, sodium oxide, ionic compound, Na2O. Remember to check your charges and crisscross down just like we've always done. Now I stick to start balancing. I said draw lines and dots to help you and see the atoms. Here I start with 1 atom of sodium, and on the right I have this 2 here, so that leaves me with 2 sodium atoms. Well, if I have 2 atoms here and 1 here, I need to add a coefficient. I can only add to the front. I add a coefficient of 2, which gives me 2 sodium atoms and 2 sodium atoms. Then I check my oxygens. 2 oxygen atoms here, 1 oxygen atom here. So to change my 1 into a 2, I add a 2 to the front of my sodium oxide. So that causes this to go to 2. That also changes my sodium from 2 to 4. So I've gone all the way from my left to my right. So I go back and check my atoms. 2 sodium atoms here, 4 here. Whoops, that means I need to go back and fix. So instead of 2, means I really need to have 4. So 4 sodium atoms 4 sodium atoms, 2 oxides or 2 oxygen atoms, and 2 more oxygen atoms. So now I'm balanced. That means for this reaction to take place in real life, I'd have to have 4 sodium atoms reacting with 2 oxygens to make my one here ionic compound of sodium oxide, making 4 sodium atoms combining with my 2 oxygens. All right, next one, same thing. When sodium metal is placed in aluminum sulfate, it yields, there's my arrow, sodium sulfate and aluminum metal. So sodium sulfate is a product, as is aluminum metal. Sodium metal is placed in, so that's an action, they're reacting together. So that's a reactant, and aluminum sulfate is a reactant. So I write my equation, sodium metal, well that's just sodium, is placed in aluminum sulfate, so it's Al2SO4, 3. It yields, there's my arrow, sodium sulfate, Na2SO4, and aluminum metal, again just Al. So sodium metal, Na, aluminum sulfate, sodium sulfate, aluminum. Neither aluminum nor sodium by themselves is a diatomic, so they're just as seen on the periodic table. Now I go ahead and count my atoms. 1 sodium here, 2 sodiums here. So that means I add a 2 in front to get my 2 sodium atoms. 2 aluminums here, 1 aluminum on the right. So I added 2 in front of my aluminum, so I have 2 aluminums and aluminums. Now polyatomics, we try to keep them together as much as possible. So we have sulfates on the left and on the right, so I'm going to count them as one thing. So 1, 2, 3 sulfates here, because 3 sulfates. 1 sulfate on the right. So to change that, I'm going to make this a 3 in front. So 3 here, and that's going to change my number of sodiums. So I add 3 times 2 means I have 6 sodium atoms on the right. So I've gone all the way from left to right, so I'm going to go back and check my amounts. 2 sodium atoms, 6 sodium atoms. Oh, I need to go back and fix that. So instead of 2, it means I really need a 6. 3, 4, 5, 6. 6 sodium atoms, 6 sodium atoms. 2 aluminums, 2 aluminums. 3 sulfates, 3 sulfates. My next one, I have water and carbon dioxide are made when dicarbon tetrahydride and oxygen are combusted. That's my reaction. Right? They're reacted, they're combusted. So water and carbon dioxide are made, that must mean they're products. Both dicarbon tetrahydride and oxygen are combusted, that's them reacting together. So dicarbon tetrahydride, D2H4, and oxygen are combusted. Oxygen, go up and check. Oh, that's a diatomic, so I need O2. Are combusted, that's my reaction. These were made, or are made, so this is my products. Water, H2O, and carbon dioxide, CO2. Now I notice that oxygen is in both of my products, so I'm going to balance that last. So starting at the left, I have carbon, 2 carbons, and on the right, 1. So I added 2 in front. Hydrogens, I have 4 hydrogens on the left. I have 2 hydrogens on the right, so I added 2 in front. Next, I balance my 2 oxygens on the left. Remember, this 2 distribute through, so 2 oxygens in the water, 2 times my 2 oxygens here gives me 4 oxygens in carbon dioxide. So that's a total of 1, 2, 3, 4, 5, 6 oxygens are in my products. Well, I have oxygen atoms in my reactants, so it means I must multiply it by 3 to get 6 total oxygen atoms. So when I've added the 2, came back. So I go back and check. 1, 2 carbons and 2 carbons. 1, 2, 3, 4 hydrogens. 1, 2, this 2 made my 4 hydrogens there. And 1, 2, 3, 4, 5, 6 oxygen, 2, 3, 4, 5, 6 oxygens. I'm balanced. Go ahead now and write the formulas for each of these, and then draw your dots and balance, and we'll go over it tomorrow in class.